Welcome to our lesson on solving polynomial equations. We have already done a lot of work with graphing quadratics and looking at the properties using standard and vertex form. We spent time learning how to factor with various techniques, and now we are going to put all of that information to use. So we are going to be solving quadratics with 5 methods for the rest of this chapter, and 2 of those methods are by factoring and by graphing. The other methods are the quadratic formula, which you should be familiar with, solving by completing the square, which is going to be newer for most of you, solving using square roots, and that is something that you've done, but we will take all those to another level and we will introduce imaginary numbers this year. So right now we're going to start with real solutions, and we're going to just talk about how we're solving. So a zero of a function, the zero of a function is the value of the input that makes the output f of x or y equal to 0. The zeros of a function are the x-intercepts. These are key ideas, and we need to make sure we put this on a note card so we have it. Unlike linear functions, which have no more than one zero, so unlike a line has only one place where it's going to hit the x-axis, quadratic functions can have 2 zeros, as shown here. The zeros are always symmetric. About the axis of symmetry. So remember, the formula for the axis symmetry is x equals negative b over 2a if you have your quadratic in standard form. The x value in the vertex form is h. And then we can have 2 solutions. So right here you can see that they would reflect on each side of here. And what do we know about the x-intercepts? Well, as ordered pairs, an x-intercept is considered a comma 0, the x value comma 0. So I want to give you the big picture. When you're told to solve, find the roots or zeros, all of those things for a quadratic are you trying to find x when y equals 0. So eventually, instead of having y or f of x equals ax squared plus bx plus c, the big picture is we're going to replace the y with the 0 and try to find out what x we can put in there to make that 0. So if you're told to solve, find the roots, or find the zeros, you are really trying to find x when y is 0. And so we set it equal to 0, but I can't solve because there's x squared and x. But this is what I'm looking for, the x-intercepts. Find x, which is the a value, and y is 0. And that's why these 2 ordered pairs have a y value of 0, so they solve the quadratic. Now, there's 3 things that can happen. And so I want to put that up here. We're going to talk about it. You can have 2 solutions, all right? So if your graph hits 2 points, you have 2 solutions. Maybe your graph only bounces off the vertex, so maybe you only have 1 solution. And the other option, whether it goes upward or downward, maybe it never crosses the x-intercept. And we say no solution, but we're really going to talk about this later. It's no real solution because there are imaginary ones. So there are 3 types of answers: 2 solutions, 1 solution, or no real solutions. And for graphs, that's all we would write, and we'll come back and solve that algebraically. All right, so that was an introduction, so let's go ahead and start here. It says to find the zeros, what I was talking about there. Find the zeros of f of x equals x squared plus 2x minus 3 by using a graph and a table. So the method we're going to do is we're going to graph this. All right, we know the graph opens upward because a, what's in front of the x squared, is positive, so it opens upward, just like this. The y-intercept is negative 3 because c is negative 3. And actually, I would like to not write just negative 3. Let's go ahead and put that as an ordered pair. 0, negative 3. Remember, our y-intercept is an extra point. The x-intercept helps solve it. The formula for the vertex is x equals negative b over 2a. that really helps us find the axis symmetry. So this would be -2 over 2 times 1. And remember, we want to do it in parts. And I get x equals -1. So that's my axis symmetry. I'm going to go ahead and graph that right here to help anchor my graph. And then this x value from the axis symmetry drops in for the vertex. And to find the y value, we are going to plug it in. -1 squared plus 2 times -1 minus 3. Okay, so that would be a +1 minus 2 minus 3, and we end up with a -4 for y. So that is my vertex, -1, -4. Plot that point there. And then the next thing we want to do is we want to get some other values. So one of the values we can use is the y-intercept, which is 0, -3, and we can just reflect that. And that's what we did earlier, was we just sketched our U-shaped curve. The problem is I'm trying to solve it. I'm trying to find the zeros, which means I need the x-intercepts. So if I just come in and sketch this, I can get an estimate, but I don't know what my x-intercepts are. And that's where we're going to build a chart. Always put your vertex in the middle, or your axis symmetry, which is -1, -4. We know if we put 0 in, a 0, 0, that gives me -3. And so we need to take a minute to put the other values in. So just take your original equation, as we had done before, and drop these in. So I'm just coming back up to here, and I'm putting my -3 in. So if I'm going to put this in a calculator, I want to do it exactly as it looks. So this would be parentheses -3. Make sure you close parentheses of powers on the outside, plus 2, then parentheses -3. Close those. Whoops. Double check yourself. And then minus 3. And we should get out 0. Okay, to save myself some time, when I put -2 in there, I'm just arrowing back up and replacing every -3. I still have the same equation with the 2. Double check at my minus 3, and I get -3. All right, I've got these two, so let's jump to 1. Same deal, I'm going to delete and replace that 2 with a 1. Delete and replace that. I've got my minus 3, and that gives me another 0. So in reality, these two right here, those are my x-intercepts. I would go to -2, 3, which we had from reflecting, -3, -3, 0, and 1, 0. And so if you're asked to solve by graphing, then no matter what, you need to create that graph. But we can also see that these are my x-intercepts. So the table and the graph both indicate the zeros are at x equals -3 and x equals 1. So here's an example where I have a quadratic that has 2 solutions by graphing it. Now, not everything's going to give you nice solutions when you graph. You can also use a graphing calculator to help aid you if you were looking to go quickly. But we're going to graph old school with our hands here. Now, it says find the zeros, which means find x when y equals 0. So get it, find the zeros. Where does this y value 0? What x does that happen at? And it says use a graph and a table. So in order to know where to my table, I need to find my anchor, my x value, and that is -b over 2a. So it's going to be a -2 over 2 times -1. And so I get a +2 over -2, so I get x equals -1. So we have the same y or vertex axis symmetry value. So let's go ahead and graph that. And to get, that's my axis of symmetry. And then to get my vertex, that'd be -1, and then we have to figure out what the y value is. So I'm going to take that -1 and plug it in. Now catch this, there's an extra negative sign here. So, you know, we're allowed to use calculators, but in some classes you're not. In many college courses, in your algebra level college courses, you're not allowed to use a calculator. So I want to point this out to you. These two negatives do not cancel each other out because of the order of operations. So you would square this first and then take the opposite. So if you jump in and say, oh, these negatives cancel, 1 squared is 1, you will get it wrong. You've got to square that. I get a positive 1, and then I take the opposite. Negative times a negative is a positive 2, and then plus 3. And our final answer would be 4. So that is the y value. Again, if I'm putting it in a calculator, you can't skip that extra negative sign on the outside, because we're going to take the opposite of this positive 1, minus 2, then negative 1. I'm a firm believer in your parentheses here, and we get that 4 out also. Okay, so where does that help me? Well, now I want to make a table. So I know that my vertex is at negative 1, positive 4. Do you also notice that because it's a negative 1, since a is negative 1, it's going to open downward? So that's a nice tip to remember. I'm going to put my vertex in the middle at negative 1, 4. And then I'll pick some points to the left of negative 1, like negative 2 and negative 3. Maybe we need to go further. And then to the right of it, like 0 and 1. Okay, so we need to take this time, and you need to go negative and then negative 3 squared minus 2 times negative 3 plus 3. So take that time. I already had it in the calculator, so I'm going to replace every negative 1 with a negative 3. Double check that I have it entered right. I should always get that U-shaped curve, and that's perfect because that is one of our zeros. So go ahead, take a minute and fill in the rest. It'd be a negative 2 squared minus 2 times negative 2 plus 3. And you put that in the calculator, you should get out a positive 3. And then I'm going to pause here. It's really important that you guys can do these. So where I see mistakes are the negatives. So if you're not trying these on your own, you need to stop. You need to try them on your own. These negative signs really get people with parentheses. Okay, you take the time, you put 0 in, you get out 3. You put 1 in, you get out 0. So I want to remind you, x, 0, those are your x-intercepts. 0, 3, that's your y-intercept. So we need a more accurate graph. That is why we're making tables rather than just an extra point. So here we go. We've got our negative 1, 4. We've got 0, 3, which does reflect to negative 2, 3. We've got negative 3, 0, and that's 2 to the left, and 1, 0 is 2 to the right. So you see that symmetry. And we can get some more ordered pairs, but that's really what I was looking for. It doesn't really have a spot, so I'm going to write over here, x equals negative 3 and 1. That is my final answer. Okay, and so those are the x-intercepts, and again, my graph opens downward. All right, now, you can also find the zeros by using algebra. For example, the zeros, the roots, or the solutions to f of x equals x squared plus 2x minus 3. You can also set the equation equal to 0. The solutions to the related equation, so we replace f of x with 0, represent the zeros of the function. So this is our first example from the front. Okay, we graphed this and we got the solutions of negative 3 and positive 1. So if we come over to the back, we are now going to use algebra to help us. So the solutions to a quadratic equation of the form ax squared plus bx plus c are the roots. So this is y equals 0. So again, you're trying to find x when y equals 0. So roots, the zeros, solve the quadratic. The roots of an equation are the values of the variable that make the equation true. You can find the roots of some quadratic equations by factoring and applying the zero product property. Okay, so you know the zero product property. It says if the product of two numbers is 0, then at least one of the numbers is 0. That is, if a times b equals 0, then a equals 0 or b equals 0, or both a and b equals 0. Okay, so basically when our product is 0, one of the items had to be 0. So if I have 2x equals 0, then x has to be 0. And we could solve this, divide by 2, x is 0. If I have x times y equals 0, then either x has to be the 0 or y has to be the 0. And or is inclusive here. So if I have 0 times y, I've got 0. If x is 5, and then times 0, I get 0. Or 0 times 0 is 0. So that's the big picture. So I'm going to keep coming back to this idea. We are trying to find x when y is 0. So what I'd like you to notice is that this quadratic is already factored and set equal to 0. So if you think about this, either what's inside the x minus 7 equals 0, or what's inside the x plus 5 equals 0. So why is this called the zero product property? Your product is equal to 0, and product means these are multiplied. These are already factored. So not only are they already factored, they're already factored and equal to 0. Okay, so that's how we're trying to find x. So what would make x minus 7 0 if x was 7? Or what would make x plus 5 0? Well, we would subtract 5 and it'd be x equals negative 5. So I'm really just solving these little equations here. And so 7 and negative 5 would be our options to make it 0. 7 minus 7 is 0, and if I distribute 0 to everything, I get out 0. If this is not 0, maybe it's negative 5. And so it's not that the x is 0, it's what do I put in for the x to make this whole thing 0. And that would wipe everything out. Okay, so here's another one that's already factored for you. And this one I can do in my head. X would be negative 1. This one I have to think about a little bit harder. So I say we write each piece down. So this is one piece of the product, 6x minus 7, that's one factor, or x plus 1 equals 0. So here we just subtract 1, x equals negative 1. Over here I'm going to add 7, and I get 6x equals 7, and I'm going to divide both sides by 6. So x equals 7, 6, or x equals negative 1. And you could leave this as a mixed number, 1 and 1, 6. You could leave the improper or make it a decimal. Okay, so these were already factored and already set equal to 0. That's a big deal. So, next page. When you are given a quadratic equation, we are talking about it being equivalent to ax squared plus bx plus c equals 0. So again, we're replacing the y with 0. So we are trying to find the x when y equals 0. And that's why we're replacing this y value, or f of x, with 0. A, b, and c are all going to be real numbers, but a cannot be 0. Because if a is 0, it's no longer a quadratic. X squared makes a quadratic, we would have it be linear. Okay, standard form is what we've been working on as we've talked about quadratics. So in standard form, when a quadratic is written in highest to lowest power, that's what we want in standard form. And so this is standard form. Power 2, power of 1, and this is really c times x to the power of 0. Okay, so we want to solve. We want to find the zeros of each function by factoring. So again, we want to find x when y is 0. So set this equal to 0. That's your first step. Make it look like this. ax squared plus bx plus c equals 0. So in this one, I'm going to move the 6 over, and I'm going to keep it in order. So 2x squared plus x minus 6 equals 0. Okay, now that's what I have, and then it's your choice here. You have a trinomial, and you have a coefficient on the x squared, and there's no GCF. So take out a GCF if you can. And in this one, the idea here is you can either do factor by grouping, or you can do trial and error. I'm going to jump to trial and error because there's not that much to try, but this is the idea that the new part we've already done, and the factoring should be old news. And this is where people really struggle because they're not good at factoring. So I'm going to come in here with the 2x. and I'm going to come in here with an x, and maybe on a piece of scrap paper or somewhere else, the options are set. And then here, I'm either going to use a -2 and 3 or a -1 and 6. So at this point, I know that I would never pair up the 2 or the 6 here. So that cuts down my tries. So I'm going to go ahead and I'm going to put I'm going to make it a -3 here and a +2 here. So you're going to have to work that out and try it. But if it doesn't factor right, it's not going to solve right. So 2x squared, -6. The outside is positive 4x. The inside is -3x. There's my 1x. So again, factoring, if you're struggling with that, you're going to need to work on that because it has to be second nature to get here. And now that I know that I factored it correctly, I'm going one step further because it's equal to 0. I'm going to solve it. So either the 2x minus 3 equals 0 or the x plus 2 equals 0. So that would be 2x equals 3, divide both sides by 2, and I got x equals 3 halves, or subtract 2 from both sides, and I get x equals -2. And so those are my two zeros. Now, how do I know I got this correct? You're going to go back up to the original. And I don't really have room to write this check, but I'm going to go back up to the original. I'm going to type in 2 times 3 halves, or 1.5, squared, and then plus 3 halves, or 1.5, and I should get out a 6. Perfect, I did. Now if I take -2 and I put -2 in there, and then I still have, yep, that's it, equals 6. So I should know whether I've got this right or wrong by taking my answers and checking it. Okay, same idea over here. I'm going to set it equal to 0. That's your first step. And I've got y squared plus 13y plus 42 equals 0. All right, so now that I've got that, I'm going to jump in. This is an easier factoring because a is 1. Notice it's still equal to 0, and that's what's different. We never had equal signs before when we were factoring. And so this is going to factor of y plus y. Factors of 42, I want to use +6 and a +7. And then I want to solve it. So a lot of people say, oh, you just use the opposite sign. Well, yes, the answer is simply y equals -6 or y equals -7. And the reason I'm just using the opposite sign is I'm setting what's in parentheses y plus 6 equal to 0. This whole piece could be 0, and that's why I use the opposite sign, because I'm solving. Or the y plus 7 could be 0, and so I subtract 7, and this is my final answer. And again, always go back and plug it into the original to make sure you get that original outcome. All right, so these are just some steps to help remind you. Steps to solving a quadratic equation by factoring. First, write it in standard form so it is equal to 0. So ax squared plus bx plus c, we want that to equal to 0, highest to lowest power. Factor the expression. You know, you're looking for GCFs, so I'm going to write that in here. Look for GCFs. It could factor by grouping. It could be 4 terms to group. It could be a trinomial, which you can use any method. It could be a difference or perfect of squares. Okay. Zero product property is what I'm going to do is I'm going to set each factor equals 0. That's this idea. Either this part's 0 or that part's 0. Solve each part and then check answers by putting it back to the original. So we have followed all these steps for both these problems. Now, when I looked at example 3, I thought, oh, that's great. It's pre-factored. But it's actually not pre-factored because it's not set equal to 0. So we actually have some extra work to do here. We need to FOIL this. So 2x squared, and then I get a -6x. The inside is 5x, and last is a -15, and that equals 6x. Okay, next thing I want to do is I want to bring this 6x over, and then I want to put all my like terms together. So I have a +2x squared. That's going to be a -12 plus 5, so -7x, and then a -15, and that is equal to 0. Okay, now you can factor by grouping, you can factor by trial and error. It's up to you. I'm going to jump into trial and error because they're smaller numbers. I only have to worry about one negative sign and two sets of factors, and we can flip the signs easily. And so I know it's going to be a 2x and a 1x, and then I'm going to test it, and I have determined that this is a plus 3 and a minus 5. So please make sure you're able to factor. And then what I'm going to do is set and say, well, one of these two has to be 0. So 2x plus 3 could equal 0, or x minus 5 could equal 0. So with that, I would subtract 3. 2x equals negative 3 divided by 2. So x equals negative 3 halves, or add 5, x equals 5. And again, you would want to take this back to the very, very original to make sure, in case you made a mistake, how your answers are. All right, we are going to stop after this next example. I want to break this into 2 lessons. So we've done a lot. We are going to do this one to find the roots by factoring, and then I'm going to finish example 6, 7, and some word problems. We actually have a lot more, 8, and some other examples. We are going to finish all of this in a second lesson. So one more example here to finish us off. It says solve and find the roots by factoring. So the first thing we need to do again is set it equal to 0. So I just need to move this 36 over. There are no like terms, so I end up with n to the third plus 4n squared minus 9n minus 36. You really want to double check your signs because that can throw everything off. So I noticed I had 4 terms, so I'm going to come in and factor by grouping. So it's a good thing we've reviewed that again and we learned that. In the first set I can take out an n squared, and what's left is n plus 4. In the second set I need to take out a negative 9, and what's left is n and a plus 4. Okay, so what do these two have in common? They both have n plus 4. When I take that out, what's left over is n squared minus 9, still equal to 0. Now I need you to remember that I'm not done factoring, so that's why we spent a lot of time on that. The n plus 4 is good, but see that n squared minus 9? That is a difference of squares. So I really have n plus 4 and then n plus 3 times n minus 3 equals 0. Now this wasn't really a quadratic, this is a cubic, and it's going to have a chance to have 3 answers. So we would look at each of these and say, well, what would make this 0? If n was negative 4, what would make this 0 is a negative 3, what would make that 0 is a positive 3. So you might see the answer as n equals negative 4 or plus or minus 3. And that would be your final answer. So you can see that the better I am at factoring, the easier this is. If I'm good at graphing like we'd worked on, and I'm good at factoring, this is not much more work to do. But you also want to make sure you see this. So this is the same idea. Find the zeros of this, but we have one further step, and it actually says, instead of just giving the zeros, what are the actual intercepts of the graph? And so again, we're going to come back to these examples and these word problems in a second lesson as you practice solving using graphing and factoring.